Okay, one more day of 5.4. We're going to be working with altitudes today, but here are the answers to day one, working with the medians of the triangle. Okay, so altitudes, basically it's the perpendicular segment from the vertex to the opposite side. And I'm going to draw a triangle here. There's part of the definition that's kind of interesting. So if I draw the altitude, it goes from the vertex to the opposite side. So and it's going to be perpendicular. So it's going to be like that there. Now with the obtuse triangle though, it's kind of unique because you can't draw it perpendicular inside here. Like there's no way that's ever going to be perpendicular. And so there's a part of the definition. Erase this here. We go back. It says from a vertex to the opposite side or to the line that contains the opposite side. So what that means there is you're going to be extending, for the obtuse triangle, draw the altitude, you're going to extend the side length so it contains the opposite side. So this line contains that opposite side. And then what you're going to do is you're going to go straight down like this, and that is going to be your altitude. And this one, you're going to have to do the same thing here. You're going to have to extend this side right here, and then go straight down like that. So there's an altitude, there's an altitude, and there's an altitude. Now, just like all the other lessons, the altitudes are going to meet somewhere, and that point is another special point. It's called the orthocenter. We're going to do the constructions in class, just like the other ones. We're going to do all those on one day, but I'm going to show you guys a little bit about the orthocenter and where the orthocenter can lie using this demonstration here. Okay, so here's my altitude. And as you can see for this acute triangle, here's my three altitudes, which creates the orthocenter. This point right here, if I make it a right triangle, it's going to lie on the vertex. And if I make it obtuse, it's going to be outside. So that's kind of some critical information. There's nothing special about the orthocenter, but you have to know where it lies based off of what kind of triangle it is. And so it's really interesting. The altitude for a right angle, for the right angle part, the altitude is actually the side itself. So you're going to see here, this altitude is the side of the triangle itself, and that one there. And so that's why it lies right on the vertex, because it's going to be perpendicular. So that's kind of a neat fact. And you're going to notice here the theorem says that a line containing the three altitudes meet at point G. All this is saying is the altitudes of a triangle are concurrent. That's it. So there's nothing special about it. And then, as I mentioned, if it's acute, it's going to be inside. If it's a right triangle, it's going to be on the vertex. And if it's obtuse, it's going to lie on the outside. There are tons of these points, by the way, which is why I have this on here. If you want to check those out in class, I can show you guys a couple of them. There's tons and tons of different center points. We only focus on a few of them, however. And then prove that the median to the base of an isosceles triangle is an altitude. So we're given an isosceles triangle with base AC. BD is the median. So we know that BD is the median to AC. So we know that that is a midpoint here. So that means these two are the same. And since isosceles, these two are the same. And since it's isosceles, the base angles theorem says that these two are the same. So we know these two triangles are congruent by side angle side. And then to show that it's an altitude, we have to show that angle 1 and angle 2 are one of those has to be a right angle. Well, we know from CPCTC, angle 1 is congruent to angle 2, CPCTC. And we know that 1 and 2 form a linear pair. So basically we have 1 plus 2 equals 180, and since 1 equals 2, we have 1 plus 1 equals 180, and therefore 2 times the measure of angle 1 equals 180, and therefore 1 is equal to 90. And therefore you've shown that that is a 90-degree angle, and hence BD must be the altitude of the triangle, or one of the altitudes. So there you go. And then triangle PQR is an isosceles triangle. Segment OQ is an altitude. What else do you know about OQ? What are the coordinates of P? Let's start with the coordinates of P first. Since this is isosceles and this is h comma 0, this has to be negative h comma 0 for starters. These two triangles would be the same, or sorry, those two angles are the same because the base angles theorem, this is reflexive. So these two triangles definitely congruent by either HL or angle side. So we know all their parts are the same. So that makes this equal to this. So we know that OQ has to be an angle bisector. Oops. It has to be a median because it goes from the vertex to the midpoint. No, yeah, a median. Let's see. It has to be a perpendicular bisector because we know that these two parts are also equal, and we know that it's perpendicular because it's an altitude, so it's got to be a perpendicular bisector. And I think that's all three of them. You just have a lot of stuff happening with this. So there you go. If it's an altitude for an isosceles triangle, it's also the angle bisector, it's also the median, it's also the perpendicular bisector. Here's day 2. This was day 1. We saw that yesterday. Here's day 2, just working with the altitudes. So hopefully this was nice and short for you guys, and thank you for tuning in.